Here's page 8 of Vector Apps Addendum. So first we're going to look at number 7. Consider the system here where k is any real number. Use row operations to reduce the system to the following. Okay, interesting. So if we use row operations, we can actually kind of eliminate the second row, at least the first two elements, right? So let's see. I'm going to first write this as a augmented row matrix. 3 minus 1, 8, and 6, negative 2k. Okay, now I can kind of see how the second row can be eliminated. If I multiply the first row times negative 2 and then add it to the second row, do you see how that would be negative 6 and 2 on the top? And so that would make the second row disappear. Okay, so basically, just to show you what the first row looks like, if you multiply it times negative 2, I am going to write it down here. So it'll be negative 6, positive 2, and then the last element would be negative 16, right? So I am going to add this to the second row. Okay, I'm going to keep the first row the same, just because it's kind of, they want us to keep it the same, right? So the second row will become 0, 0, and k minus 16, right? Okay. So we're pretty much what they wanted was to do that, right? Okay, so we have done that. For what value of k is there infinitely many solutions? Okay. Well, let's see. If we had 0x plus 0y equals 0, that would be 0 equals 0, which is always true, which would be infinitely many solutions. Okay? What if we had 0x plus 0y equals 7 or something like that? Well, that's 0 equals 7, which is impossible, which is no solutions. Okay? So the way you would make the second equation yield infinitely many solutions is if you would make k minus 16 equal to 0. So here I'm going to say, okay, k minus 16 equals 0 is the way you would do infinite number of solutions. So that would happen when k is equal to 16 only, right? Okay, so k equals 16 is the solution for part 2 here. And when does the system have no solutions? Okay, so, that would be any other case. So if k is not equal to negative 6, when k is not equal to 16, that would mean that the k minus 16 would be something other than 0, which would mean you would have 0 equals 7, or 0 equals 10, or 0 equals negative 3. 0 equals something other than 0, so that would mean, no solutions. Okay, so this would be infinite solutions, and this would be no solutions. Interesting. Okay, so explain this result geometrically. So actually, each one of these is a line, right? And if you graph them when k equals 16, you would have coincident lines. You would have a red line, and then you would have another line like right on top of it, and they would be coincident, okay? And because of that, you would have infinitely many solutions. If you graph them when k is not 16, then basically you would have parallel lines. And if you have parallel lines, they never intersect, so there's never a common solution between the two. Okay, so that's the explanation geometrically. Let's look at 9. Use row operations to find the values of m when the system, blah, 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 has a unique solution, and find the unique solution. Okay, so first thing we need to do is we need to write it in augmented matrix form, which would be m. And they just make these tricky by making them algebra problems by, instead of putting just numbers here, they give us variables, right? Okay, so there's our augmented matrix. Use row operations to find values of m to make this system have a unique solution, or one intersection, not parallel, etc. Okay, so first thing we're going to do is we're going to try to eliminate this 2 here to make it into echelon form. How do we do that? We are going to multiply the top row by negative 2 over m, right? If we do that, then the second row can be eliminated. So first what I'm going to do is I'm going to multiply the top row by negative 2 over m, and I'm going to get negative 2. Negative 2 over m times 2 would be negative 4 over m. And 6 times negative 2 over m would be negative 12 over m. So I got a kind of a big mess there, didn't I? Okay, and I leave the second row the same. Now what I'm going to do is I'm going to add the first row to the second row, and then that is going to make the second row partially disappear. So the first row I'm going to keep the same. Okay, and then I'm going to add it to the second row. The second row is going to become 0, m minus 4 over m, and then I would have 6 minus 12 over m. So 6 plus 12 over m. Oh, I'm sorry. No, it's 6 minus 12 over m because I'm just adding, I'm not subtracting. So 6 minus 12 over m. So now I can use algebra to figure out what the bottom row represents. The bottom row represents m minus 4 over m y equals 6 minus 12 over m, right? And now I'm going to solve for y. And I just get this really bizarre looking thing here. And then we'll try to see if we can simplify it a little bit. Well, you know, if you're like any normal person, you don't really like fractions. So let's try to get rid of these fractions. We're going to multiply every single element by m. So I'm going to multiply the top by m. I'm going to multiply the bottom by m. If I multiply the top and the bottom by m, it's the same thing as multiplying by 1. So I'm not changing the value of y. Okay? So I'm going to have 6 times m, 6m. 12 over m times m is 12. And in the bottom, I'm going to have m squared minus 4. Okay, one more thing. We can factor this, right? So let's factor it. And say, why are we going to factor it? Well, factoring sometimes allows you to cancel out things from the top and bottom that you might normally see. So we can factor it out of 6 from each of those terms, right? From the bottom, did you know that m squared minus 4 is actually equal to m minus 2m plus 2? This is really good to know for the SAT. Now, we could say, oh, look, these two cancel out. So I'm left with something much simpler, which is 6 over m plus 2. Now I'm going to try to figure out what x is. And I'm going to take this equation here, which has x in it, and it has y in it, so I can figure out what x is from y. Okay? So I'm going to recopy this equation here, and then I'm going to substitute in this here. So 2x plus 6m over m plus 2 equals 6. Now I'm going to solve for x. First thing I do, I'm going to subtract 6m over m plus 2 from both sides. So I end up with 2x equals 6 minus 6m over m plus 2. I would like to combine these two expressions into one fraction, so I'm going to multiply this one top and bottom by m plus 2, which is like multiplying by 1. And then I'm going to end up with, I'm going to combine the tops, 6m plus 2 minus 6m. And on the bottom, I'm going to have m plus 2. And then I'm going to divide both sides by 2. So then I end up with, and I can cancel these, right? I divide both sides by 2, so I'm going to end up with 1 over, oh, I'm sorry, this is 12, right? So this becomes 6 over m plus 2. Hey, what do you know? It's the exact same expression as the y. Okay. So now we have a solution for x, and we have a solution for y. One thing I forgot to do part A. Part A says to use row operations to find the values of m when the system has a unique solution. Okay, so when we use the row operations, remember how we ended up with this expression at the bottom, which is this expression here? Let's look at that again, okay? So I'm going to copy it over here. Copy, and I'm going to put it over here. Paste, I'm going to make it a little smaller. Okay, let's look at that. So when would this not have any solutions? Okay, Well, remember that if we have like 0 equals 5 or something weird like that, then it will not equal anything, okay? So we're not going to have a solution. So let's try to make this coefficient into 0. That would make things very bad, okay? So if this is 0, we could say m minus 4 over m equals 0, and then we could say that m equals 4 over m, and then we could say that m squared equals 4, right? Which means that m is equal to plus or minus 2. Okay, so basically what this is saying is if m is plus 2 or m is minus 2, then we would end up with 0 on the left, and we would probably end up with something that's not 0 on the right. Okay, and let's check that out exactly. So I'm going to check out the case where m equals 2. If m equals 2, the left side becomes 0, of course, and the right side becomes 6 minus 12 over 2, which would also be 0. Okay, so when m equals 2, no big deal. Infinite solutions, okay? If x or m is negative 2, then what happens? Then the left side, as we said before, is 0, and the right side becomes 6 minus 12 divided by negative 2, which would be 6 plus 6, which would be 12. Now 0 equals 12 is not true ever, so that would be no solution. Okay? So no solutions if m is negative 2, and infinite solutions if m equals 2. Okay? And part A says to find the values of m when the system has a unique solution. So it would be whenever m is not plus or minus 2. Okay. And then we found the unique solution. The unique solution is y equals that, x equals that. Okay. When m is any number except for plus or minus 2. Okay, is fine. Discuss the solutions in the other two cases. Okay, the other two cases would be these solutions here. So, okay, so when m equals 2, then we have infinite solutions. When m equals negative 2, we have no solutions. Let's take some time to go into 15K, and this is, when you go to the 3 dimensions, this is kind of bizarre if you start thinking about it, that like the way planes meet can be so orderly. Let's start with 2 planes meeting in space, okay? And actually there's only 3 ways that 2 planes can meet in space, and these two are kind of obvious, right? 2 parallel planes. You can imagine that easily in your head, right? Coincident planes. So like 2 planes that occupy the exact same space, right? And of course, if it's not parallel and it's not coincident, can you believe it? But the planes must be intersecting in a line like this, okay? So these are the 3 possibilities if you have 2 planes. Now, let's go to the possibility of 3 planes. And this is where it gets kind of mind-boggling, and you might think, oh my gosh, 3 planes? There's like an infinite number of ways 3 planes can meet. But actually, there's not. There's only 8 ways. Okay, so let's look at the 8 ways. So, first of all, there's all 3 planes are coincident. They all occupy the same space. There you go. Okay? P1, P2, and P3, they're all planes, and they're all in the same location. Okay. What if 2 of them are coincident? So 1, 2 coincident, and then the other one is not coincident. So it is, just slicing them like that. So 1 intersecting. Okay. Then of course there's the case where there's 2 coincident. So this blue one is like 2 planes together, and then this green one is parallel. Okay. So this is the case when all 3 are coincident. These 2 are the cases when you have 2 coincident. Okay, now we'll go on to the cases where none are coincident. Okay, so that's the bottom ones here. Okay, so we have the case, of course, where 3 are parallel to each other and separate. Okay, that's kind of the most obvious one. Now, what if you have 2 that are parallel? If you have 2 parallel, and 1 is not parallel, then that means that the third one must be intersecting both of them like this. Okay. Now there's the 3 kind of weird cases. So there's a case where all 3 are kind of like going off in different directions. So like And then so basically the first two intersect in a line, and then the third one, when it intersects with the first two, it creates an intersection of a point. So all meet at one point, okay? This kind of looks like a coordinate system, doesn't it? Where there's the XOY plane, the YOZ plane, the XOZ plane, okay? It kind of looks like that, right? And then these are the other two weird cases. So if you have three planes that are not parallel, it's pretty weird, but they're either going to meet like this, or they're going to meet like this. If they don't meet like this, they're going to meet like this or this, because it means that they're all kind of going in the same direction. So they're kind of like in this radial thing here, or it forms a triangle like this. And this one is called all meet in a common line, and this one is called line of intersection of any two is parallel to the third plane. Okay, so there's only 8 ways for planes to meet. Pretty bizarre, huh? And the rest of this page will be done in a separate video. Thank you.